this video, we're going to talk about how to use substitution to solve a system of linear equations. Alright, so let's go ahead and get started with this first one. So basically, first step in using substitution is to go ahead and solve for one of your variables in either equation, really. So usually, good thing to do is just choose what's the easiest variable for me to solve for and solve for that one. Okay, and so that's the first step. So let's go ahead and do that. If you're looking over here at this equation, you're saying, okay, so what's the easiest variable for me to solve for? Looks like this solving for x is probably, well, looks really easy. So let's go ahead and solve for x in the first equation. So I'll have x plus 2y equals 4. So I'm going to subtract 2y from both sides. So I'll have 4 minus 2y. Okay, so now, since I've used equation 1, the next step is for me to plug in x, this x that I found, into the equation I didn't use, which would be equation 2. Okay, so this is equation 1. So now I'm going to look at equation 2. And equation 2 is 3x minus 6y equals 12. So I'm going to plug in the x that I found, right, which was 4 minus 2y, okay, that was found from equation 1, minus 6y equals 12. Alright, so now I just need to solve this equation for y, because now it's it's an equation that only has one variable in it, so I can solve easily for that variable. So go ahead and do that. Distribute 3, so 3 times 4 is 12. 3 times negative 2 is negative 6. Alright. If I subtract 12 from both sides, I would get, so let's go ahead and do that, subtract 12 from both sides. On the left-hand side, I have negative 6 and negative 6, so that makes negative 12y. And 12 minus 12 is 0. Okay, so if I divide both sides by negative 12, I get y equals 0. Alright, so what's my solution? Oh, I'm not done yet, because I've only solved for one of the variables, right? I still need to solve for x. So the way I'm going to do that is I'm going to go back here. I'm going to say, okay, so x equals 4 minus 2 times 0. Alright, so 4. 4 minus 0. So x equals 4. So now what's my solution? 4, comma, 0. Right? Your solution should always be a point. So, because you have x and y, so that's why it's a point. So there you go. This is your solution. Okay, these are just the parts of your solution. Alright, so it's good practice to go back and check your answer. So the way you would do that is just, go back to the original equations and plug in, make sure, both equations are being satisfied. So if I were to do that, for equation 1, I would have 4 plus 2 times 0 equals 4. I can see that that's true because that's basically 4 equals 4 because 2 times 0 is 4, or 2 times 0 is 0, right? So 4 equals 4. And then if I were to have 3 times 4 minus 6 times 0 equals 12. Okay, that cancels out because that's 0. And 3 times 4 is 12, so both check out. Let's go ahead and do another example. Okay, so in this example, we're still going to be using substitution. What's the first variable that I'm going to solve for? Maybe it doesn't matter as much here. It's not like in the previous one where I had an easy thing to solve for right there in the get-go. I can choose, since I solved for x last time, I'll go ahead and I'll start by solving for y in the first equation. Okay, so it doesn't matter as long as you remember what equation it came from, because then you plug it back in, it needs to go into the other one. So okay, so this is the first equation. I'll go ahead and solve for y. So I'll have negative 2y. I'm going to subtract 8x from both sides. And then I'll divide everything by negative 2. Negative 8, negative 2. Okay, that's going to become a positive 4. Okay, because that was negative 2 on the bottom, so negative make positive. 8 divided by 2 is 4. All right, great. So this is what y equals. Okay, so now I'm going to use the second equation and plug that in. So the second equation is negative 12x plus 3y equals 7. So negative 12x plus 3. Now I found what y is. 5 halves plus 4x. Okay, and then equals 7. So now I just need to solve for x. So I'll have negative 12x plus, I'm going to distribute the 3. So negative 15 halves plus 12x equals 7. Alright, the 12x, the negative 12x here cancels with that 12x there, because that's positive and then that's negative. So then I'm left with negative 15 over 2 equals 7, right? And that's not a true statement, right? Negative 15 halves does not equal 7. So this is an example of a system of linear equations that does not have a solution. Now it makes sense why it's called an inconsistent system, right? Because seems like an inconsistent thing that just happened. So there's no solution. And if you were to ask to write your solution set, you could write the set, the null set, which just looks like that. Okay, let's do one more example. All right, so let's go ahead and get started with our last example. We have up top, we have x minus 2y. So it looks like it's probably going to be easier to solve for x here. So I'll go ahead and do that first. So I'll have for the first equation, I have x minus 2y equals 4. So x equals 4 plus 2y. So for the second equation, I have negative 4x plus 8y equals negative 16. Alright, so let's go ahead and plug in the x that we just found. 4 plus 2y, okay. Just plugged in the value of x that we found here, plus 8y equals negative 16. Okay, let's go ahead and distribute and solve for y. So 16 minus 8y plus 8y equals negative 16. Oh, so I have minus 8y and plus 8y. Those two cancel. So then you end up with negative 16 equals negative 16. Right? And this is always true. Always true. Okay, so we have a situation where we have infinitely many solutions. So how are we going to write our answer? Now, if you remember in the previous video, I talked about what it means to have infinitely many solutions. I'm not necessarily drawing these lines right now. I'm just drawing what it looks like. It's basically the two lines are lying on top of each other, right? Okay, so the way that we write our solution set is we say, okay, so x, and then we write whatever y is with regards to x. So I need to go up and just for one of these two equations, I need to solve it for y so that I can write my solution set. It doesn't matter which one I solve for y, I'm actually going to get the same thing either way. So I'll go ahead and use this this top one. So if I were to solve for y, I would have, let's see, I'll go ahead and, first thing I'll do is bring over the x. So I'll have negative 2y equals 4 minus x. Then y will equal, so 4 divided by negative 2 is negative 2 minus, well that becomes a plus 1/2 x. Okay? Alright, so that's the way I would write my solution. So instead of writing y here, I would write negative 1/2 plus 1/2 x, which is basically that's the equation of the line. Okay. Alright, so this would then be your solution set.